In this lab, we're going to look at electrolytes. Remember, electrolytes are substances that, when dissolved in water, conduct electricity. Or when they're in an aqueous form, conduct electricity. They will not conduct electricity in the solid form. So you can read the connections about what you already know in life. A lot of sports beverage advertising talks a lot about electrolytes, right? And so this is something that pops up pretty frequently, even in, just while you're walking around in the grocery store. So electrolytes are compounds that conduct electricity in aqueous solutions, right? And so when we have an ionic solid that dissolves, the water molecules interact with the ions through that process of hydration, and those ions dissociate. The resulting dissolved ions are these electrically charged particles. So sodium chloride will dissociate into sodium ions and chlorine ions, and those are charged, right? And that's what results in the solution conducting electricity. So when we look at the pre-lab question, it says, for a compound to be an electrolyte, what must happen when it dissolves in water, right? And it needs to break apart into its ions. Now we're going to start the procedure. So we're going to start the virtual chem lab, and we're going to select electrolytes from the list of assignments. And actually, I think I'm just going to, once this starts, just go directly to the titration lab. I think it's called something different than electrolytes in the actual lab, but it won't matter. Everything will work even if you're in the titration lab. So it takes a second for it to load. A few things to notice here. This is a burette, okay? We have a drawer with beakers and a drawer with pipettes. Here's our balance that we've seen before, and here's our stock room. This is where we'll go to get some chemicals. Two new things that you see. This is a pH probe here, and this is our conductivity probe. So that's what our lab looks like. So it says click inside the stock room, double click on 3 reagents. Now I'm just going to do 1 reagent for you. So we'll do NaCl together. So I'm going to go to the stock room, and I am going to find NaCl, which is right here. I'm going to double click on it, and I'm going to return to the lab. Okay, NaCl is going to go there, and I'm going to place a beaker here. I'm going to zoom in. I'm going to take the lid off, and I'm going to put some whey paper right there, and I'm going to hit the tear button. Now, what I'm going to do is I'm going to drag this across and scoop up some of the solid. Now, it always takes me a second to do that, so don't get frustrated if it takes you a few tries. Sometimes if I go out, like zoom out and then zoom back in, I don't know if I calm down or the program works better, but it tends to work a little better. All right, now we're going to put it in our beaker, and we're going to zoom out. And so if we look here, right, we've accomplished step 3, okay, where we've zoomed out. It says move the beaker to the stir plate, pick up the 25 milliliter graduated cylinder near the sink, hold it under the water tap until it fills. Pour the water by dragging the cylinder to the beaker. Then we're going to turn on the conductivity meter, place the conductivity probe in the beaker, and record the conductivity in the data table. And so the data table they're talking about is this table here, and you're going to record the conductivity here. And then we're going to double click the salt bottle to place it back in the stock room. So let's look at that. Okay, so we're going to move the beaker here. This is our 25 milliliter graduated cylinder. We're going to put it there. We're going to fill it up. Once it's full, it snaps back to the bench. We're going to bring it over here, and we're going to pour it in. Okay, we're going to turn on our conductivity meter. We're going to place the conductivity probe right in the solution. And so you can see that we get, for NaCl, 3.89. Now everybody's going to get a little bit different value because the mass is going to be a little different. So you need to do this, again, on your own. Don't use my value, but use your own value. So once you've recorded it, right, we can get rid of the beaker by hovering it here over the waste bucket, and that cleans that up. Now, you are going to complete all the solids the same way, okay? When you get down here, right, read through this part, and when you go through this part, these are liquids, and so you're gonna prepare the liquids in a little bit different way. So we're gonna do one of the liquids. We are gonna do NH4Cl. That's just the first one there. And so let's go back to the stockroom. Let's find, it's a liquid, so it'll be in one of these bottles. Well, I lied to you. It is a solid, so it's going to be right there in that bottle. I looked at the wrong line on the lab, so we want to look at the NH3 solution. So that's the solution we're going to look at. So let's find the NH3 solution. It's going to be a liquid. There we are. Okay, so we're going to put it there. We're going to return to the lab. Okay, and so we're going to move it to the bench here. That's ammonia. And so it says, place the beaker on the spotlight left of the stir plate. So we want to place a beaker here. Okay. And then it says, pick up a bottle of solution from the stockroom shelf and pour it in the beaker until the beaker is at least 1/4 full. So we'll take it and we'll pour it into the beaker. Until it's at about 1/4 of the way full. Then it says, click the pipette bulb to fill up the pipette. And so we're going to use a 25 milliliter pipette. So we're going to select the 25 milliliter pipette here. We're going to put it here. It already has a bulb, so we're going to click the bulb. It's going to go in. It's going to fill up the liquid. So it's got 25 milliliters in it. Place the used beaker in the red disposal bucket. Drag a new beaker to the spotlight under the pipette and click the bulb to empty the pipette into the new beaker. So we're going to get rid of this beaker, right? Because we want to use a measured amount to do this. We want to have the same amount when we measure this. And then we're going to release the liquid into there. And then if we read the instructions again, it says drag the beaker to the stir plate and place the conductivity probe on the stir plate. Well, you're going to place the beaker on the stir plate, and then you're going to move the conductivity probe into the beaker. And so what we see for NH3 there is 0.83, 0.84, somewhere in there. Okay. When we're done, we can move the probe back, and then we can dispose of the bottle, dispose of the beaker, and then we can move the bottle back to the stockroom. And so you're going to measure the conductivity for solids that you have to dissolve in water, right? You have to dissolve these in water, or for aqueous solutions that are already dissolved in water. So it asks, which compounds in your table are electrolytes, which are not electrolytes? So which ones conduct electricity? Those are going to be electrolytes. Which ones do not conduct electricity? Those are not electrolytes or non-electrolytes. Would any of these electrolytes conduct electricity in the solid form? No, they have to be in aqueous solutions for the ions to form, and so that's why they will not conduct electricity in solid forms. You need to identify these as ionic or covalent compounds, and you can classify each compound in the table as ionic or covalent. You could just write that below here, right? So you can write the conductivity and whether it's ionic or covalent there. And then it says write a balanced chemical equation for each electrolyte. And so what you're writing there is a balanced chemical equation like this. So you have an NaCl solid, and it breaks apart into Na plus aqueous and Cl minus aqueous. So that's the first balanced equation that you'll write. And so you will write a balanced equation for each one of these.